Hello everyone and welcome back to the channel. In this video, we will analyze NjRat. NjRat is a remote access Trojan which has capabilities to communicate with a command and control server, executing commands and capturing keystrokes. It consistently ranks in the top 10 threats on the AnyRun sandbox report. In this video, we will do a detailed analysis of the NjRat malware. But don't worry, it is beginner friendly. So if you're starting off in malware analysis or just curious, you're in the right place. And if you're interested in learning malware analysis in an organized manner, I have a course just for you. Feel free to check it out. Link in the description below. With that, let's dive in. All right, so here I'm in my virtual machine. This is the virtual machine installed with the Flare VM setup. I have this folder called NjRat on the desktop, and I have two files in it, a to-do file, which is open here, which basically talks about some of the things that we are going to do in this video. And we have the sample.exe. Let's start off with the static analysis. For static analysis, my favorite tool is PE Studio. So let me open up PE Studio. Here I will open up file, go to sample.exe, and let's see what we have in front of us. We can see the MD5 of the file. We can see the initial few bytes. We see something very important here, which is Microsoft Visual Studio.net. We also see that this file is an executable. It is 32-bit. All these things are going to be important for us. This specifically is going to be very important for us. Let's move down in our analysis tool. We see that some of the other details are here. They are important, but we can pass by them. Let's look at virus total, and we have a lot of red here. Out of 71 AV or EDR applications, we have 57 detecting this as malware. We can see that Elastic detects this as NjRat. We can see that Microsoft also detects this as NjRat. All right, so that's fine. We can look at some of the other things here, but I'm mostly interested in the strings. So in PE Studio, we can see the strings labeled very nicely, and it also talks about what are some of these things linked to. For example, if we see this API here, we can see that get foreground text, get window text, and all these Windows APIs are linked to Windows discovery. Send message is linked to process injection. And then again, these are linked to Windows discovery. Some of the other Windows APIs are also there. Base64 string is also there. Then we have some keyboard logging API calls over here, which is linked to input capture and hooking. Then we have process discovery, sandbox evasion, etc., etc., and we can keep on going on. We also see some of the other commands as well. Task skills /f/im. This net sh command is basically adding an exclusion in the firewall. We have our first network IOC, which is dl.dropbox.com, and which is downloading parse.exe. And some of the other things are also there. What I also like to do is that I like to extract these and take them in a text file. So for that, basically what I'll do is that I'll open up a terminal here. And in the terminal, I will use the tool strings.exe, and I will say strings. Let's look at the help first. In the help, we see that the strings tool searches for ANSI and Unicode strings in binary images. And if we want to specifically invoke it for ASCII text only, we can use the -a. We want to see both ASCII and Unicode. So let's execute this on sample and send this to sample strings.exe. In fact, it should have been sample strings.txt. All right. And now we can open them in Notepad. And let's look at these strings. The good thing about strings is that it basically organizes the largest strings at the end. And we can again keep on looking for these. Another thing is that I can look for certain things. For example, if I want to look for an IOC here, .com is there. And what else? We see some of the other applications as well, application names, task manager, process hacker, etc., etc. And we can see some other IOCs as well. We see that tcp.eu.ngrok.io, and this looks like a port. This looks like HKey local machine, software, Microsoft Windows, current version run. This is a persistence mechanism, and so on and so forth. And we see some name of the files as well. All right. So we have completed our static analysis, and we've looked at the strings as well. Now, since this sample is developed in Visual Studio.net, we can open this up in DnSpy. We saw that this sample is a 32-bit executable. So let's open it up in DnSpy, and let's open up here. So I will remove this sample and open desktop, NjRat, and sample.exe. So sample.exe is opened up as W, and there is 0000 at the end. And here basically we are looking at the code of the NjRat malware, which has been reverse engineered and extracted by this DnSpy tool, which is basically a tool used to basically reverse engineer .NET binary into its code. All right, so let's start from here, go to the entry point, which is main over here. If I click here, I'll go directly to main. Once I go to main, I see that the next method that is being called is ok.ko. Let's go here. And here we see some more code, and let's start off with the analysis. We see that there is a Boolean being set up here, and the Boolean is basically getting the answer from this function command. And command is basically looking for command line arguments. And if there are command line arguments, it is basically returning the command line argument. So if it says that there is no command line argument, then this becomes false. The Boolean becomes false and it does not go inside here. Let's assume that we don't have any command line arguments. The next thing that we see is mutex. Now mutex is basically used by malwares to make sure that only one instance of the malware is executing on the system at one time. And so basically what happens is that this command or this line will set up a mutex right now, because this is the first time that this malware is executing. The second time this malware tries to execute on the same system, this command will fail. Now, when this command will fail, flag 2 will become false. And if flag 2 becomes false, flag is equal to not of flag 2, which is not of false is going to be true. And if this becomes true, it will go here in this if condition and it will execute this end app. So basically it will kill itself. All right, so that's fine. Let's go to our next function, which is instantiate or ins. All right, so what is happening here is that ok.idr is basically true, so we don't need to worry about that. So true and %. This is a compare directory function. So basically it's comparing these two directories and returning whether these are true or false. And let's look at what is being compared. So ok.lo, what is lo? Lo is basically the assembly.get entry assembly.location. So basically this is going to return the full path of the current sample. So over here, if you look at the full path of the sample, this is going to be the full path of the sample. So let's note this down here. Full path is equal to this. All right. Now this is returning the full path. The full path is being compared to a new file info. The new file info is basically getting the path of this. So this interaction.environment gets the path of this ok.dir, which is windir. So it is basically trying to resolve the windir location, which is going to be usually c:\windows. And then it is looking for, it is concatenating // so c:\windows / exe Microsoft system.exe. So basically it is looking for comparing the path of the current file, which is this one, with c:\windows / Microsoft system.exe. All right, so it is basically looking for this path. So basically it is comparing the path of the current file, which is this one, to the, this one, and it is comparing it to the path which is newly created, which we have talked about here, c:\windows Microsoft system.exe. Now, if this fails and the comparison fails, which means that the current file is not located in this path, then let's see what it does. It is basically copying. So it is basically going to go and delete the file, existing file. If there is an existing file there in this path, it is going to go and delete it. Then it is going to copy the current file, which is this one, sample.exe, into this location. So it does that over here. Then it starts the process from this location and it ends the current process, which is running from this location. So basically, in order to hide itself, it is looking for the current path of the process. If it exists somewhere outside this location, it basically copies itself to this location and starts itself and then exits the current process, which is this one. All right. Okay. So let's move on. The next thing it does to facilitate itself is to add itself as an exclusion in the Windows firewall. After that, it basically opens up the registry, which is the registry of the current user, and then software Microsoft Windows current version run. And in this persistence mechanism, it sets the key, which is this, and the value is the full name of the file, which is the current path of the file. If this fails for some reason, then it goes into the local machine and does the same over there. So local machine registry path is different from the current user registry path. So you can see that there is a current user registry path and a local machine registry path. All right. So next up is that if this flag is set, the application is going to get the current executable path and it is going to set the attributes to hidden. So basically it is trying to hide itself. The next thing that it does is that it copies itself. So it firstly gets the path of the startup folder and then it copies the full file into that startup folder. And what is the startup folder location? I asked this from Bing chat earlier, and that is C users, username, app data, roaming, Microsoft Windows, start menu, programs, and startup. Oh my God, that's a mouthful. But that's fine. So it basically copies itself to the startup folder, which is another form of persistence. And then if this flag is also set, it is going to go and kill this file. Now, if you've studied NjRat before, this could be the name of a previous sample that was set up in previous versions of NjRat. So it is trying to kill processes which have been running before or the previous version of itself. All right. Now, if there is this flag set, then it basically sets the executable path attributes as hidden, which basically means it is hiding the file. So next up, we have USB persistence being created. In USB persistence, we see that the autorun.inf file is being used and the USBX or the svchost.exe is being used. Now, this looks a bit complicated, but it's fairly simple to understand. It is basically setting the attributes as hidden. It gets the path to the program files. So now we have the path of the program files, which is going to be obviously c:\program files. All right. Now it has that in text3. For text3 in logical drives, so if text3 is in logical drives, it is going to copy the current executable. So current executable was running from this location. It is going to copy the current executable to the text3 plus text2. So basically it is saying that for every program files that exist, or if there is any sort of program files or file systems that exist on the logical drive, it is basically going to copy this its own executable as svchost.exe. So if there is any kind of folder structure or the program files that exist on these logical drives, it is basically going to copy itself over there as svchost.exe. And then it is going to basically set up some lines in the autorun.inf file, which says that open is equal to text3 plus text2, which means it is setting up the path as the default open location. So whenever the autorun starts, this thing will be open, and shell execute is equal to text3, which means it is saying that execute svchost from basically this location. All right. So this is another form of persistence. Now we go back. We were basically looking at the INS folder till now. If we go back, we can go forward a bit and we see that the name is being set up over here. So the executable name is being set up as the name, which is this dot name. So which means that it will be Microsoft system.exe, the directory name will be c:\\windows, and we have a thread starting over here, rc thread. Now, if in rc thread we start going down, we see some weird code which is basically used for obfuscation. It is in the technical terms, it is called a finite state machine. And if we look at some of these things, these are a bit confusing, but we don't need to bother ourselves with that. Just keep on going down and we can see some interesting things. We see that client.receive is there. All right, that's fine. Read call is there, and then we have a client.connect. Whenever we are doing some sort of a network connection, so the first thing is going to be always connect, and then we can do send and receive. So we look at this connect first. If we go to connect, we can see over here that there is a connect being called over here, and we see that okay.mh. What is this? mh is basically used to split up the string, and ok.hh is the host. So basically this is going to be the host, tcp.eu.ngrok.io. All right. So that's fine. It is going to get the value of this and set it in this. And cn is this, ok.send. So basically it is connecting now to this location. All right. And then it is going to basically execute all these things over here. All right. So let's go back. After the connection takes place, it is basically going to receive or send. It has sent something before, now it is going to receive something. And after that, it is going to start this thread. This thread is going to be launching this IM function. And in that IM function, it is basically sending this AO. If you look at this AO, this is basically going to be the ok.mem. Ok.mem is the data that has been received from this client, and it is being passed to this function, which means it is this AO over here. If you go to this IND function, we see something interesting. So this IND function is basically splitting up the command that is being received, or the text that is being received, and we will see some interesting things here. If we read this carefully, this is basically a short form of new process, NWPR. And the new process that is being started here is process.start array1, which means that if the array was something like, so it's split on pipes. So if pipes are there, so it basically says NWPR, and then it says like this, and it will say notepad. So which means that start a new process, and the process that has to be started is going to be notepad. So basically this is going to be used as a separator, the pipe thing that we saw, along with the command and then the argument to the command. So the next thing is going to be the site and the fun. These are basically going to be returned back to the C2 I home, which means that Internet Explorer home can be set up. And these are going to be all the commands here. So we see shutdown, restart, log off, shutdown -L, error message, and all these things. If we keep on going down, we can see some very weird commands as well, which look very, very archaic. We'll see something like a beep, piano, open CD, close CD, disable KM. I think this is keyboard something, disable KM, turn off monitor, normal mouse or reverse mouse, disable CMD, which will disable the command line, obviously, and so on and so forth. So this whole function basically can be looked at. Disable task manager, enable task manager, cursor hide, cursor show, all these things can be looked at. So now we have looked at the core functionality of the NjRat malware, and we can keep on exploring this. Let's go back to our function, which is, I think we were looking at ok.rc, and we basically went from there into ok.im. So basically this was the remote connection, or the RC function, which was being called. And next up we will have this KL function, which is basically going to set up some keys to none. And after that, if you look at WRK, we can see that this looks like a keylogging function. So pro tip is that wherever you see get async key state being called, we can assume that some kind of a key logging is going to take place. And we can also see that in the logs, there is something being appended into the logs, and we can see some keys being accessed over here, which gives me a clear hint that this is basically a keylogger function. If we go back, we can go down and we can look at some of the other things that are part of this function. We see that this is a manager class and this is a protect function. Basically, the protect function is going to look for processes which are running on the system, which can be task manager, process viewer, process hacker, process explorer, etc., etc. And then these are being sent a message. So send message API is being called over here, and the message that is being sent in text3 is end process, which means that this function will try to end all these processes. If we go down a bit more, we can see some other things. This is basically set to false over here. The last thing that I want to show you, which is special to NjRat, is basically another protection mechanism, which is here in this function PR. So it is called NT-set information process. And basically it is setting this on the current process handle. The value that is being set is 29. This is important to remember. The value 29, it is basically sending the reference of I and then 4. If you go to our browser and we look at NT-query information process, we go up, we can see that NT-query information process may be altered or unavailable. That's fine. Retrieves information about the specified process. It basically sends the process handle. The type of information that it wants to retrieve is that this parameter can be one of the following. And if you look at 29, which was being set up, it says process break on termination. Retrieves a long value indicating whether the process is considered critical. So basically what it wants to do is that the malware wants to set up the current process as a critical process of the system. And so what it will happen is that when this process gets killed somehow, the system will go into a break, which means that there will be a basically blue screen that will show up to the user and the system will restart. So basically it is trying to protect itself from getting killed. So in case there is some sort of a remediation action being taken by an IR analyst or by the user who's trying to kill this process, if they try to kill this process, the system will restart automatically. All right, so that brings us to the end of our analysis. We've looked at static analysis, we've looked at strings, we've looked at code analysis, we looked at the initialization, the persistence mechanisms, the protection mechanisms, we saw some network IOCs, and we've looked at all the features, almost all the features of this malware as well. So I think that brings us to the end of this video. Thank you very much for your time, and I hope to see you in the upcoming videos.